Now, hopefully the sound in this one's better than the last one. I think I was using the wrong microphone. Right, so we're doing the simultaneous equations by elimination, and we're adding them. The last one is pretty easy. Realistically, it's always a wee bit trickier than that, because there's not always the solutions staring you in the face. You might have to not just add them or subtract them, but beforehand you might have to multiply one of them to get the constant to match the other one you're wanting to get rid of. So if you look at this one, hopefully what's striking is the fact that we've got the y's there. Now if I actually times, it's minus something y, plus something y minus y. So if I actually times this one by 3, I could get that up to become minus 3y, and then that allows us to add these just to cancel out the y's or eliminate. So if I'll just keep it nice and neat. So we've got 3x plus 3y equals 9. But now we're going to multiply the equation 2. Okay, so that's going to give you 21x minus 3y equals 3. Okay, so this is the new 2. So once we actually add these together, you'll find that we end up with 24x, the minus 3 and the plus 3 equals 0, and that equals 12. Okay, what we've then got is 24x equals 12, so we divide that by 24, and then we divide that one by 24. So what we've got is x equals 12 over 24, and hopefully you remember that is equal to half. Right, so that's us got x, so that's half the battle done. What we then have to think of is, well, what does x, if x equals this, what does y equal? Okay, so that's something that we now need to work out. Just double checking just in case I've made a wee mistake for 24x. Yep. Right, so what we've got here is we'll use one of these equations. So I'm just going to use, we'll just use the top one. Right. So if we say 3x plus 3y equals 9. If x is a half, so that's 3 halves plus 3y equals 9. So that's 3 over 2 plus 3y equals 9. What that then means is we subtract 3 over 2 from both sides, so subtract 3 over 2. And remember, see 9, I'll try and sneak that in there. 9's equivalent, if we're making that as halves, is 18 over 2. Right, so just bear that in mind, but you'll have a calculator anyway, but it's always good to be able to do it in your head. So we end up, so this is a lot trickier than I actually thought, so we end up with 3y equals 18 over 2 minus 3 over 2, which equals 15 over 2. So that's 3y equals 15 over 2. So if we divide that by 3, trust me to pick the hard one, divide that by 3, what we end up with is y equals 5 over 2. So it's essentially it equals 2.5. And I'm probably going to, I can, right, so we've now got these two values, but we now actually need to be able to put these values in the equation. Okay, so if I choose one, I'm going to choose this equation here. So if I go down here and I say that was 7, I'll just rewrite it, so I can 7x minus 7x minus y equals 1. Right, so that's 7 halves minus 5 over 2 that should equal 1, so let's see if it does. So that's 7 over 2 minus 5 over 2 equals 1. 7 over 2 minus 5 over 2 is 2 over 2 equals 1, and that does. Okay, so 2 divided by 2 is 1. Right, so that's you proving for that equation that x is a half and y is 5 over 2. Okay, obviously you'd want to also do it for this equation. So when you put x is 5 over 2 and you put, sorry, if you put x is equal to a half and y is equal 5 over 2, that should equal 9. But that was actually a trickier one than it first of all looked, but hopefully that's given you a wee hand.